Today we're talking about discrete and continuous data. Discrete data is when we have whole numbers of things, usually certain values, things that we're counting by, things like people, or number of shirts, or number of donuts, things that you can only have whole numbers of. And then continuous data is data that does not stop, and it is connected, usually measurement, so like time or distance or miles, things that you can have parts of, dollars. So discrete, when you graph it, there'll be separate points. A continuous function will be connected, like you see on these two examples. So it says you are given $28 to buy apples for a meeting. Your local fruit stand has Gala apples for $4 a pound and Red Delicious apples for $2 a pound. So the two variables we have here are the Gala apple pounds and the Red Delicious pounds. We're not counting how many apples we have, we're counting the pounds. So our two variables are x is pounds of Gala apples, y is pounds of Red Delicious. We can go ahead and label that on our graph. So this is pounds of Gala. In pounds, to abbreviate pounds, you do LB, and I'll put LBS, pounds plural. And over here you got Red Delicious. Again, in pounds, LBS. Great. Now let's think about if this is discrete or continuous. Well, you can have parts of pounds. So when you go to the store, you don't buy you do buy a whole number of apples, but you actually pay per pound. So they'll weigh your fruit and they'll say, well, it's 2.31 pounds, so you owe this amount of dollars. So this is actually continuous because you can have parts of pounds because we're not counting the apples, we're counting how many pounds we have. So circle continuous, I highlighted it. Best way to do this, well, first we're going to write our equation in standard form. 28 is our total, and then both 4 and 2 happen over and over because it's per pound. So our equation would be 4x, $4 per pound of Gala, plus 2y, $2 per pound of Red Delicious, is equal to our total cost, which would be $28. Best way to do this, because it's in standard form, would be to get the x and y intercepts so we know how far we have to go on the x-axis and how far on the y-axis. So to get your x and y intercept, we plug in zeros. X-intercept, plug in 0 for y. So 4x equals 28, and you get x equals 7. So that is the point 70. Do likewise for the y-intercept, but plug in 0 for x. So these, because they're multiplying by 0, they basically just cancel out. So it'll be 2y equals 28, divide by 2, and you get 14. So that's 0.014. So we have our 2 points. We know that on the x-axis, we've got to get up to 7. On the y-axis, you have to get up to 14. If you look at this grid, there's 14 squares each direction. And so for my x-axis, I could space it out. So I have to go up to 7, and there's 14 squares. So we can skip 2 and then label 1. You want to try and spread it out as much as you can on these kind of graphs. On the y-axis, we have to go up to 14, which means each square has to be 1 because there's only 14 squares. I'm not going to label every single one because I don't feel like it, so I'm going to skip 2 and label 2, 4, 6, 8, 10, 12, and 14. It's the same thing as each square is worth 1. So now graph your 2 points. 7, 0. And 0, 14. This is continuous, and so we're going to connect those 2 points with a line. We need our domain and range. Domain goes from 0, so this is your left to right, your x values. X goes from 0 to 7. And range, lowest to highest, goes from 0 to 14. This graph, we need to give it a title. So we're buying apples, so let's make that our title. Now we're done. You're given $180 for your birthday, so that's your total. To spend on school clothes, you have to spend all of the money on tops and bottoms. Tops cost $15, bottoms cost $20. So those things are both happening over and over. Let's write an equation to represent that. It's going to be in standard form again, because we have 2 things happening over and over and a total. So my equation would need to be 15 per top plus 20 per bottom is equal to our grand total. You have how much money? You have 180. And so what we're saying here is that tops are x and bottoms are y. Let's make sure we label that. Tops x, bottoms y. You can only buy whole numbers of tops and bottoms, and so this is discrete. Now we're going to get our x and y intercepts so we know how far to go on each axis. This is where we plug in zeros. So my x-intercept, I can plug in 0 for y. So that basically goes away. You got 15x equals 180. Divide by 15 and you get 12. So that's the point 12, 0. Find your y-intercept now. Plug in 0 for x. That would be 20y equals 180. If you divide by 20, you get 9. So that's your y-intercept. So we know on the x-axis we've got to go up to at least 12. On the y-axis you have to go up to at least 9. Here's the thing, because this is discrete, you're going to have points along the way. So you'll have those 2 points, the x and y-intercept, but there's also going to be some in between. So that means that we have to get the slope to know how to move. So take your standard form equation, which is 15x plus 20y equals the total, 180. And you're going to have to get the slope. So we want to put it in slope-intercept form. So move the x term to the other side. It's positive, so I'm going to subtract it. And then we get 20y equals 180 minus 15x. Now divide by the number in front of y to get y by itself. We just did 180 divided by 20. We know our y-intercept should be 9. And then you got negative 15 over 20x. 15 and 20 can both divide by 5. And so really this simplifies to 9 minus 3/4 x. Okay, we'll need that in a second. Let's go ahead and scale our graph. We've got 14 squares. Looks like each square is going to have to be worth 1. I can't really spread it out any more than that because I have to go up to 9 and to 12. So the x-axis, we'll do 0, and then still making each square worth 1, I just don't want to label every single square. Do the same thing on the y-axis. And we know that x is the tops. So down here we got number of tops. And on the y-axis we have number of bottoms. Let's go ahead and give it a title. We're buying clothes. That works as a title. And my x-intercept is 12. My y-intercept is 9. And then from here we're going to do the slope, which we know to be -3/4. So our graph is going to go down 3, right 4. And since it's scaled the same, I can just move by the squares. We do not want to connect it because it's discrete. And so my points here, my domain is just going to be listed as 4 separate points. My domain, my x values are 0, 4, 8, and 12. My range is 0, 3, 6, and the highest one is 9. Okay, and we're done. Oh, we forgot one thing.